Chapter 2 introduces some techniques that are used in descriptive statistics. The first section of Chapter 2 is about frequency distributions and their graphs. So we use frequency distributions to organize quantitative data, and frequency distributions help us to recognize any trend or any patterns of the data that lie within the data. All right. So what is a frequency distributions? Frequency distributions is a table that shows classes or intervals of data entries with a number of entries, which is the frequencies in each class. So in order to construct a frequency distributions, we need to understand and figure the following features. First, sample size is denoted using n, is a number of data entries. Second, class width is a difference between the two consecutive class in your distributions. So class width is calculated using the difference between the maximum entries and the minimum entries divided by the number of classes. So the number of classes are ranging about from 5 to 15 classes are the right appropriate number of classes for any of the data, depending on, so how do you decide the number of classes will depend on the size of the data. If the size of the data or the sample size is less than 50, then the number of classes should be around 5 to 7. If the sample size of the data is larger, then you will decide the number of classes will be around 7 to 15. So, and also we usually round the class widths up to the next convenient number. So also you want to round class widths up to the next convenient number. For example, if you calculate the class width of equals to 8, then you have to round this class width up to 9, always round it to the next convenient number. All right, and then now we can talk about class. In each class, we have the lower limit and the upper limit. So the lower limit is the least number that can belong to the class. For convenience, the lower limit of the first class is the minimum value. And then in order to find the lower limit for each class, we add the class width to the lower limit of the previous class. For example, the lower limit of the first class is the minimum value. Then the lower limit of the second class would be equals to minimum values plus the class width. All right. And then the upper limit. Definition of the upper limit of each class is the greatest number that can belong to the class. And in order to determine the upper limit of the first class, it is 1 unit less than the lower limit of the second class. And similarly, to find the upper limit of each class, we just add the class width to the upper limit of the previous class. All right, class boundaries. Class boundaries are the numbers that separate classes without forming any gaps between them. Usually the class boundary will be values that in between the upper limit of one class and the lower limit of the previous class. Midpoint of each class. Midpoint of each class equals to the sum of the lower limit plus the upper limit and divided by 2. frequency of each class is the number of data entries in that class. Relative frequencies of a class is the portions or the percentage of the class that falls in the class. In order to calculate the relative frequency, you just take the class frequency, the same class frequency, divided by the sample size. So let's say F is the frequencies of the class and N is the sample size, which is the number of data entries. This is how you find the relative frequency. It's the percentage of the class that falls in the class. Cumulative frequencies of a class is a sum of frequencies of the class and all the previous classes. So in order to find the cumulative frequency, you take the frequency of that class and you add all the frequencies of all the previous classes. The cumulative frequencies of the last class should equals to the sample size n, because again, the cumulative frequency of the last class is the frequencies of itself plus all the frequencies of all the previous classes. That means the sum of, that means is add all the frequencies together, and all the frequencies together, the sum of all the frequencies should be equals to the sample size. All right, let's look at this example. This example is samples of 30 numbers that represents for the amounts in dollars spent on textbooks for a semester. For an example, I will ask 30 students, how much money do you spend on textbooks for a quarter? Then 30 students each will give you a number telling me how much they spend on the textbooks. And I collected those I collected those 30 numbers. And these numbers would be my data set with a sample size of 30. And then your goal is you want to construct a frequency distribution with 5 classes for this data set. So this is a data set representing 30 data points of the amount of money in dollars students spend on textbooks for a semester or for a quarter. All right, first I want to find what is the sample size. So the sample size is 30. And the number of classes is 5, right? And we can find the class width by taking the maximum values minus the minimum values and divided by the number of classes. The maximum values is 576, the minimum values is 30, and then the number of classes is 5. And the answer for this calculations is 109.2. And remember, we need to round this number up to the next convenient number. In our data sets, we have just whole numbers. So the next convenient number should be 110. So we know that the class width is 110. All right, now go to the frequency distributions here. So for the class, I start the first class using the minimum values, which is 30, okay? And I add 110 to go to my next lower limit of the second class. So 30 plus 110 is 140. If I had 110 to 140, I get 250, which is the lower limit of the third class, and so on and so forth. All right. And then once I have the lower limits for all classes, I can try to find the upper limit for each class. So the upper limit of the first class should be 1 unit less than the lower limit of the second class. So the upper limit of the first class should be 139. And I can just add 110 to get 247, right? And add 110 to get 557, and so on and so forth. So I created the lower limit and upper limit of each class. And then in order to find the frequency for each class, I will count how many data values that fall into this class, into the first class. So for example, my first class ranging from 30 to 139. And you can find how many values that falls into this class. So first 90 is one of them, right? And then 130 is two of them, right? 110, 3, 4, 5, 6, and 7. So I have 7 values, 7 data points that fall into the first class. That means the frequency of the first class is 7. And you can repeat the same process to find the frequencies for each of the class, the second class, third class, fourth, and the fifth class. Once you have the frequency, you can find the midpoint using the sum of the lower limit and the upper limit and divide it by 2 to find the midpoint of this class, of all of the classes. So this is equals 30 plus 139 over 2 should be 84.5. All right. And then go to relative frequency. So relative frequency is equals to the frequency divided by n. And we know that n is 30. And then we just take 7 over 30, a over 30, a over 30, 2 over 30, and 5 over 30. And you can convert relative frequencies into percentage, right? And you need to make sure that after you round up or down the percentages, the sum of all of these percentages here should be 100%, or the sum of all of this relative frequency should be 1, or 100%. Okay. Go to cumulative frequencies. Again, cumulative frequencies is frequencies add to all the previous frequencies. So the cumulative frequency for the first class should be just itself because there's no previous class to the first class. And then this cumulative frequency of the second class should be equals to the cumulative frequencies of itself, which is A, add to the previous frequency, which is 7. And then the cumulative frequency of the third class should be 8 itself plus 8 plus 7, and so on and so forth. And at the end, if the cumulative frequencies of the last class equals to n, that means your calculations is right. All right, in this table, we're missing class boundary. So let's try to find class boundary. So again, class boundaries are values that separate the two classes without forming any gap in between two classes, right? For the first class boundaries, I would take a values that is smaller than the lower limit of the first class, and the upper boundaries should be the values that is in between the upper limit of the first class and the lower limit of the second class. So 139.5 is in between value. And similarly, I use 139.5 for the lower boundary and 249.5 for the upper boundary. And here I have 249.5 and 339.5. And here I have 339, 59.5 and 469.5. And the last one I have 469.5 and 579.5. All right, this is the class boundaries for each class. And you can see that even though the lower upper boundary of the first class and the lower boundaries of the second class are the same, but this is totally fine because 139.5 does not make any gap in between the first and the second classes. When you calculate the frequencies of each class, the class boundaries will not make any differences. All right, this is the frequency distributions for this data set with 5 classes. Now we can talk about the first graph of frequency distribution. It is called a frequency histogram. So a frequency histogram is a plot that contains bars or rectangles that are next to each other. So the 2 bars here, the 2 consecutive bars must touch. All right, that's one thing. And this frequency histograms helps recognize the pattern of our data set using the classes of the frequency distributions. So the horizontal scale is quantitative and measures the data set, the data entry. The data entry is here, right? And the label of horizontal scale, you can use either midpoint or class boundaries. In this example, I use midpoint for horizontal scale labeling. And the vertical scale measures the frequency of classes. And again, in frequency histogram, 2 consecutive bars must touch. All right. So in this graph, I use midpoints to label our horizontal scale. And then look at the vertical scale. So the height of each bar. So the first bar here is a representation for the first class. And the midpoint of the first class is 84.5. So I use 84.5 to represent my first class. And the height of this first bar here is the frequency of the first class. And the frequency of the first class is 7, right? When I construct this frequency histogram, I need to label my scale accordingly. So for the horizontal scale, I have midpoint. And since the distance between the origins to this point and the proportions of the distance between this point is not the same as the proportions of this point, thus I need to have this broken axis here to indicate that the proportion is not the same. And then look at the vertical axis, the vertical scale. I have this mark here represent for 2, and then 4, 6, and 8. I don't have any broken axis in here because the proportion from the origin to 2 is the same as the proportion from 2 to 4, so on and so forth. All right, so I know that the frequency of the first class is 7. The frequency of the second class is 8. Third class is 8. The fourth class is 2. And the fifth class is 5. Okay. So if I look at this frequency histogram, I can see that majority of the data set lies within the first 3 classes. Right, the first majority lie within the first 3 classes. And when you create a graph for your data set, make sure that you have a title for your graph. Make sure that you have your axis label, like horizontal axis or vertical axis or scale labels. You make sure that you have the unit for your axis. Make sure that you let people know what information are you using for your labelings and so on and so forth. Okay, so this is the first graph of frequency distribution of frequency histogram. And you can use the frequency distributions to create a frequency polygon. A frequency polygon is a line graph that emphasizes the continuous change in the frequencies. It will tell you how the frequencies of each class changing continuously. Okay. The horizontal scale, again, is quantitative and measures the data entries. The vertical scale measures the frequencies of the classes. Now you plot point that represent the midpoint and the frequency of each class. And you connect the point in order from left to right with line segments. And then you extend the left side of the line segment to 1 class width before the first class midpoint, and the right to 1 class width after the last class midpoint. So I copied the frequency histogram, right? Because I use a midpoint. So then now I know that here is my first class, and this is a point that corresponds to the midpoint of the first class, and also the frequency of the first class. It's 2, 4, 6, 8. And I have, and move on to the next class, I have a point that corresponds to the midpoint and also to the frequency of that class. And I will create point for each class. Okay. And I connect this together, this point together. And I connect this point to the left here, and this point to 1 class width to the right of the class of the last class midpoint. So the blue line segments represents the frequency polygon. All right. The next graph is you can use relative frequency to create a relative frequency histogram. The relative frequency histogram is very, very similar to the frequency histogram, except the vertical scale here is the relative frequency instead of the frequency. And then we use the percentage that we calculate from the frequency distributions to graph relative frequency histogram. Each bar right here, again, represents the proportions of the percentage or the percentage of the first class of the whole data set, right? And this is the percentage or the proportions of the second class, taking account of the whole data set and so on and so forth. So again, this is the relative frequency histogram. If you want to illustrate your data set using percentage of each class instead of the frequencies of each class. The next class, the next graph that is associated with frequency distributions is an Ogif. So an Ogif is a cumulative frequency histogram, and based on the name of it, right, you know that you're gonna create a graph that is using cumulative frequencies as the measures of the vertical scale. And the horizontal scale consists of upper classes, boundaries of classes. But then the graph starts at the lower boundary of the first class and then go to the up. So it starts right here at 0, that means before the first class, the frequency is 0, right? And then after the first class, the frequencies is 7. And then after the second class, the cumulative frequencies is 15. And after the third class, the cumulative frequencies is 23 and 25, and then 30. So 30 is a cumulative frequencies of the fifth class. And by looking at this graph, you can present your data set in terms of cumulative values. For an example, you can see that around 25 students, right? Around 25 students in my survey spend up to $470 for the textbooks per quarter. Or you can say that around a half of my data set, which is 15 students, a half of my data set, a half of the students in my survey, right, saying that they spend maximum $250 on their textbooks per quarter. So you can use an Ogif or a cumulative frequencies graph to represent your data in terms of cumulative values